The Big Bang. 13.8 billion years ago, the Big Bang occurred. This was the beginning of our universe. At the moment the Big Bang occurred, all matter in the universe was concentrated together into a tiny volume. The universe has expanded outwards ever since. The Big Bang would have caused the early universe to be extremely hot, and it has been cooling down ever since. Matter would have been spread around in small particles, which over time collided with each other due to gravity, making bigger bodies of matter. By about 5 billion years ago, the beginnings of our solar system would have been observable. There was a star, the Sun, at its center, with orbiting planets formed by matter coalescing from a cloud of matter that had previously rotated around the Sun, starting to take shape. The planets had settled into their orbits through a combination of their motion from the rotating cloud of matter and the combined impact of the gravity from each other and the Sun. Formation of the Earth. The Earth was created 4.6 billion years ago, and shortly afterwards, at about 4.5 billion years ago, a collision with another early planet took place. This caused the Earth to grow in size, but the impact also caused matter to explode into Earth's orbit, which eventually coalesced to form the Moon, a satellite body that orbits the Earth, which is unusually large given the Earth's size. At this time, the Earth was a ball of liquid rock, and it wasn't until 4.4 billion years ago that the Earth had cooled enough for its surface to begin to solidify into a crust. The crust was moved around by convection currents in the mantle beneath it, forming areas of higher and lower land. The areas of higher land were the early continents, and the lower land would later become the ocean floor. The crust has been moving around ever since, changing the appearance of the Earth's surface, creating new crust and destroying the old. The cooling temperatures would also have caused gases to be released from the Earth to create the early atmosphere. Water from these gases, as well as from comets colliding with Earth, would have been in a gaseous state due to the high temperatures. Formation of the oceans. From about 4 billion years ago to 3.3 billion years ago, we see the formation of the Earth's secondary atmosphere. This is characterized by further cooling, to the extent that the water vapor held in the atmosphere condenses into clouds and precipitation. Warm air can hold more water vapor than cold air, so the amount of water falling from the sky during this period would have been at unimaginably high levels. Following gravity, this water would have found its way to the lower level parts of the crust to form the early oceans. Over time, the moving water eroded river channels into the rock, dissolving salts which were then transported to the oceans. As evaporation of the oceans took place, these salts were left behind, causing the higher salinity of the oceans. Pangaea. During this period, the first life forms appear in the oceans, the chemosynthetic bacteria. They exist by converting chemicals emitted at hydrothermal vents on the ocean floor into energy. Oxygen started to increase in the atmosphere due to photodissociation of oxygen from the oceans. From about 3.3 billion years ago, the first photosynthetic bacteria appear in the form of the stromatolites, which emitted more oxygen. Between 2.1 and 1.5 billion years ago, life in the ocean had evolved and proliferated to cause the greatest increase in atmospheric oxygen levels, which leveled off about 0.5 billion years ago. Until this time, most of the oxygen was O2, but by 0.45 billion years ago, there was enough O3, or ozone, in the atmosphere to provide protection from ultraviolet light, and life could leave the ocean. Around 0.27 billion years ago, most of the continental crust had collected together into a supercontinent, called Pangaea. which began to break up around 0.2 billion years ago. This was a key moment in the physical formation of Europe.